Hello again, math students. Today we are going to be reviewing everything that we've worked on so far with square and cube roots. I would like you to try to do this with me and your assignment today without a calculator if possible. That's what it's going to say on the top of your worksheet. Do the best you can with this. If you absolutely have to use a calculator, if you want to just check something with a calculator, that's fine. However, that orange sheet that you should have with our chart all filled out is going to be really helpful. So the first part of our review is just some basic square root and cube root kind of problems. We've got several problems that have decimals or extra zeros, so we have to talk about that. So for instance, in number 1, I have 1, 2, 3, 4 numbers after the decimal. Because I'm taking the square root, it's going to cut that in half. I'll have 2 numbers after the decimal. So then if I just look at the 196, the square root of 196 is 14, but I need 2 numbers after the decimal. That means I'm going to move that decimal to right there. No sign in front, so I don't have to write a plus or a minus or a plus or minus. Number 2, though, clearly I need both answers, a plus and a minus. That's just going to go out in front of the whole thing. The square root of 49 is 7, and then I've got 1, 2, 3, 4 zeros. Cut it in half, 2 zeros. So this is a place, if you want to check this on your calculator, you could do 700 times 700. Make sure that you get 490,000. Number 3, when we've got the square root of a fraction, we have 2 options. The first one is, I'm going to check to see if those numbers are perfect squares, so I can just take the square root of each one of them. And they're not. So I would have to then simplify this fraction. If I simplify this, still in the square root, 2 over 32 is really 1 over 16. And the square root of that would be, square root of 1 is 1, square root of 16 is 4. Now, don't fall into a trap that some students do. Just because 4 is a perfect square, it doesn't mean you take the square root again. We already took the square root to get from 16 down to 4. I'll leave it alone. That one's done. Number 4 through 6 are all cube root problems. I don't feel like you need to multiply 5 times 5 times 5 or 25 times 25 times 25. 5 to the third power, easy, that's 125. 25 cubed, that's big. So I'm not going to mess with that. However, I could write this as that. And then the cube root of each of those would just undo those cubes. So I would get 5 over 25, which would then simplify to 1/5. Now here's the other option. In the problem, I could have simplified this 5 with this 25, that'd be a 5. And then this 5 with this 25, that'd be a 5. And then this 5 with this 25, and that'd be a 5. And there's other ways to do that. But then I would have the cube root of 1 over 5 cubed. And again, that could even be 1 cubed over 5 cubed, which would give me this same answer right there. For number 5, taking a cube root, instead of cutting the number of decimal places in half, we're going to divide it by 3. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9 decimal places. That means in my answer, I will have 3 decimal places. The cube root of 27 is just 3. But again, I said I needed 3 decimal places. So you can do these little swoopy things if you need to, but it really means I'm going to have to fill in some zeros in the front. So it's going to be 0.003. For number 6, 3 decimal places is going to go down to 1 decimal place. The cube root of 125 is just 5. So then when I move my decimal, I get 0.5. For 7, 8, and 9, I want to just simplify this. We have to evaluate. We're using order of operations, but we're also using all that we know about square roots and cube roots. So for instance, in number 7, the cube root of 700, now 700 is not a perfect cube, but if I would also cube that, this cube root and this cube cancel each other out. So that's just going to be 700. Now that is not the cube root of 100. That is 3 times the square root of 100 is 10. So it's going to be 700 plus 30. For number 8, that fraction is not going to simplify, but they are both perfect squares. So if I take the square root of that, and again, that's just 2 times that answer, The square root of 16 is 4. The square root of 49 is 7. Before you worry too much about fractions, remember this is just a 2 over 1. So 2 over 1 times 4 over 7 will be 8 sevenths minus that 3 sevenths. We just subtract the numerators and we get 5 sevenths. In number 9, be careful, make sure that you follow order of operations. You can't do 70 minus 2 right now and get a 68, right? I'm gonna have to have 70 minus 2 times the cube root of negative 8. Remember, it's okay to get cube roots of negative numbers. That's going to be negative 2. So I would do a keep, change right there. So I'm going to have 70 plus negative 2 times negative 2 is 4. I get 74. Changing decimals into fractions. For the first problem, when it's a terminating decimal. Regular decimals that we work with go over numbers like 10 or 100 or 1,000. And remember the shortcut without having to fill in the chart with the place values. I've got 2 numbers after the decimal. That means I need 2 zeros in my denominator. So I'm going to have 11 and 32 over 100. I do need to simplify. It tells me to simplify, but we know we're always going to simplify. I could divide both of these by 4. So that would give me 8 in the numerator and 25 in the denominator. 11 and 8 25ths. For 11 and 12, these are repeating decimals. Repeating decimals don't go over 10 or 100 or 1,000. They go over 9s. So however many things repeat, that's how many 9s go in my denominator. So 2.2 repeating would be 2 and 2/9. And that one's simplified. There's nothing more I can do there. On number 12, I would have 14, and then I would have 81, and since 2 things repeat, I would get 2 9s in my denominator. This, however, can simplify. Both of those, the numerator and the denominator, can be divided by 9. So I would have 14 and 9/11. If I have a list of numbers, I should be able to classify them, decide what kind of numbers they are. The half sheet of notes that we had might be really helpful to you, so you've got some examples to look at. You can also look at that funnel side that we have on the back. For number 13, please look beyond the radical, beyond the square root here. This is really just going to be equal to -5. That's what we have to be worried about, not necessarily if there was a square root in my original problem. It's equal to -5. Now, if you remember, natural numbers are like counting numbers. Little kids don't start by counting negative numbers. Whole numbers add in 0. Nope, that doesn't work for this one yet. Integers are where I get positives and negatives, but no fractions or decimals yet. So this is definitely an integer. And again, if you think about that funnel thing, all of the integers also go into the rational numbers, or if you're looking at the one that looks like a Venn diagram, it's inside the rational numbers. Remember, numbers cannot be rational and irrational. They can have one or the other, not both. But everything that we're going to deal with is real. In fact, you could mark right now that all of our numbers are going to be real, because I'm not going to give you anything that's not a real number. For number 14, 0.13, a decimal doesn't fit natural or whole or integer. It is a rational number, and by definition, remember, rational means that I could make it into a fraction. We know we can change a decimal number into a fraction number. And then it's also a real number. The cube root of 2, since 2 is not a perfect cube, the cube root of 2 will not give me a nice kind of an answer. This is going to be an irrational number. That decimal would continue on and on forever, no pattern, never going to stop. The number 4 is a number that a kid would learn how to count when they're starting to deal with numbers. That means that it's a natural number. Now, if it's a natural number, everything else except for irrational is going to work, because natural numbers are also part of the whole numbers. Whole numbers are part of the integers. Integers are part of rationals. If I give you some true or false kind of questions, I just talked about this. A number can be rational and irrational? No, remember that the prefix IR for irrational means not. It can't be rational and not rational. So if it says it can be that, nope, sorry, not going to work. Number 18, the cube root of 0.125. At the beginning, when we started doing cube roots, I could totally see that some people would say, yeah, that looks right. However, when we take a cube root, I have 3 numbers after the decimal. That means I will have 1 number after the decimal because I divide the number of decimal places by 3. So this will be 0.5. So this one is also false. In number 19, a natural number is also an integer. Again, if you look back at the problems that we just did, or if you look at that funnel or the other Venn diagram, the natural numbers are inside of the integer circle, or they would feed into that funnel. So yes, a natural number is also an integer. Number 20, finding the cube root of negative 125 is possible using real numbers. Yeah, now if this was a square root, then it wouldn't be possible. But cube root, yes, this is possible. And for number 21, the answer to the cube root of negative 64 is undefined. Again, if this was a square root, then it would be undefined because we can't take the square root of a negative number. Cube root, you bet we can. In 22 and 23, sort of story problems, it says the time in seconds it takes an object to drop from a distance, so the d is the distance, to reach the ground is given by this equation. This is based on gravity and acceleration. So a ball is dropped off of a roof, and it's 144 feet tall for this building. How long does it take the ball to reach the ground? So we're going to say it's dropped from exactly the top. We're not going to worry about like the height of the person holding the ball or anything like that. That just means that this 144 is going to be the distance that we're talking about here. So the time for this is going to be the square root of 144 over 16. So the square root of 144 is 12. Square root of 16 is 4. And that we can simplify to be 3 seconds. If you would get something, and on your worksheet, I think you do get a problem here, that'll give you a decimal answer or a fraction that wouldn't be a whole number. If we're talking about the number of seconds, it would be perfectly acceptable to change that into a decimal, or you can leave it as a fraction. For number 23, the volume of a cube is 27 over 64 square meters, 27/64. Find the length of one edge of the cube. So this is saying that the side length cubed is equal to the volume. And the volume is 27 over 64. So to get the side length to be just a regular S side length, I would have to take the cube root on both sides. Cube root of 27 is 3. Cube root of 64, be careful, is 4. And this was measured in meters. So it'd be 3/4 of a meter. On these last problems, for people that were in class on Tuesday, I did say try these. We have not done problems this difficult. We did one day of solving equations that had squares and cubes in them, so we were using square roots and cube roots. And I said, you know what? You know how to solve equations. Try these. Just see if you can get these to work out. So when we are solving equations, you know that you're trying to get the variable by itself. Right now, these variables are all either squared or cubed, so that'll be the very last thing that we get rid of. However, in number 24, the 16 is attached to that x squared. Leave that alone. We would get rid of the 10. So I'll have 16x squared equals 36, and then we'll divide by 16. And I know that that's a fraction that doesn't turn out to be a nice whole number. I know that it could be simplified, And we could simplify this if you'd like, or we could leave it just as is. Either way will work. When I see these and I see that they're both perfect squares, I would tend to just leave it like that, but I'll do this problem both ways. So I've got 36 over 16. And then I would take the square root. Here's the thing, I'm gonna draw this in a different color, plus or minus. You have to put the plus or minus in. If you draw the square root, you put in the plus or minus. So x is gonna be equal to plus or minus, the square root of 36 is 6, the square root of 16 is 4. That's not simplified though. So I would get that x equals plus or minus 3 over 2. If I go back right here and I say, oh, that's right, I remember that fraction, that 36 over 16 could have been simplified. I could do this problem like this. I would have, at this point, x squared equals, instead of 36 over 16, I could divide them both by 4 and get 9 over 4. Both still perfect squares. So when I take my square root, I'm going to use a different color here, plus or minus, I'm going to get that my answer is x equals plus or minus 3 over 2. You get the same answer, just whether you wanted to simplify before or after you take the square root. For number 25, I need to get rid of that 100. So I would add 100. 4x squared equals, now negative 36 plus 100 is going to give me 64. And then I'm going to divide by 4. And I know that those are both perfect squares. However, 64 does divide nicely by 4. That's going to be 16. And then to get rid of the square root, a different color, plus or minus. I have to write that in every single time. I'm going to get that x equals plus or minus 4. For number 26. I would start by adding 6. So I have negative 27x cubed equals 125. And then I would get rid of that negative 27. X cubed equals, I'm going to leave that as that fraction. 125, 27, I'm just going to pull that negative out in front of the whole thing. I don't want x cubed, I want just x. So cube root, there's my x. The cube root of a negative number is just going to be a negative number. Cube root of 125 is 5. Cube root of 27 is 3. And I am okay with leaving that as an improper fraction. If you want to change it to 1 2/3, you can. Don't make it a decimal though. Number 27, I tried to throw in as much stuff as I could here. I have 9x squared plus 10. Now, the cube root of 11 cubed, please do not cube 11 and then take the cube root of it. The cube root and the cube just cancel. That's 11. Then, when I subtract the 10, I have 9x squared equals 1. And dividing by 9, please don't grab your calculator there because you'll get a decimal that's 0.1 repeating. Leave it as 1/9. Those are both perfect squares. Square root, plus or minus, and I get that x is plus or minus 1/3. Now, the problems that I just did are very similar. It's the same setup, it was just a different version of the same worksheet that you're going to do today. So you've got the square and cube root worksheet. Try to do it without a calculator. Check things if you need to with a calculator, but really make an effort to do it without a calculator. The answer key is in Schoology, so if you need any help, you can certainly look there. And then make sure that you take that short, really easy learning check in Schoology when you're done. Let me know if you need any help.